Okay, in this next example, we can see how we can provide sequences of data for glyph attributes like color and radius. So this would be something we could do with the say with that moon data that we worked with in a couple examples. So so here we're going to do a few other things. We're going to supply an explicit list of tool names. We're going to use CDN mode. We're going to set the X and Y range explicitly. We can turn a specific line off, use NumPy arrays for data, and supply a list of tools. So we're going to import NumPy, and then here we're going to specify the data. And the thing to watch out for is that we can specify colors using a random number. We could either use random, or we could do it using a some kind of data that we have. But here we're just doing random. And then so we're actually going to specify the colors here using a string formatter to generate this hex code. We then specify the HTML file, the title, and the mode in the output file, and then a list of tools which we can then pass to, when we create the figure, pass that to the figure command. And then putting it all together, we're going to create a glyph, p.circle, which will plot the data and using the radii and fill color. So we're going to get this big big display of color where we just have these random points and random colors, or the colors are tied to the Y location. So we've got a bunch of tools here. We've got the lasso, we've got the box zoom. This is one we haven't seen before. Let's see. Box select, which just selects those points. So you could potentially select your points using this and then save that, and if you wanted to highlight something to show somebody. You can wheel zoom. You can see when we wheel zoom, it will subsample the points, so it doesn't have to render everything, and it speeds up the computation that it has to do. So there's a lot of different tools here. You can undo, redo, reset, zoom in, zoom out, etc. So there's a lot of tools you can play around with bokeh, depending on what you're trying to illustrate. Let me just see where we're at here. Okay, so the next thing I wanted to show is this idea called linked panning and brushing. So this is a really handy way where you can have the same data displayed on multiple plots, but the plots can show different perspectives on the data, and when you change something in one plot, it will change in the other plot. So if you pan to show a different set of the data on one plot, it can pan to show that same set on the other plot. Or you can, when you highlight a certain data points on one perspective, it will highlight those same data points on the other one. There's a couple examples here. So we're going to use grid plot to arrange several plots in an array, and we'll just use figure multiple times to create each plot. And yeah, we'll use circle and triangle. We've seen those before, and in this case we can set the toolbar location to none, and also specify color and alpha, which will apply to both the line and the fill color for color, and alpha will apply both to the line and the fill as well. So here we're going to prepare the data. First we import the tools we need, prepare the data, specify the file name, create a plot, and then we're going to create a plot where we share the range of the original plot. So here we're going to say, here we have this first plot that's just normal, but then we have the second one where we say x range and y range are the x range and y range of plot S1. And same thing with S3, it's going to have the x range, in this case the x range of S1, but not the y range. It will have its own y range. Finally, we put those subplots in a grid plot, and we turn off the toolbar location, and then generate that file and show it. So let's do all that. So here we have this grid of 3 plots where we have the first one, and this is y0 is sine of x, y1 is cosine of x, and y2 is sine of x plus cosine of x. So if we look at this, when we pan around, we can see that we are getting here the x-axes are shared for all 3, but the y-axes are only shared between the first and the second. So if we move this one up and down, it doesn't affect the other 2, but it does in this direction. So that's where the panning is linked, because those x ranges are linked. So a related tool is called linked brushing, where selecting on one plot will cause selection to update on the other plots. So again, we're going to specify a sine and a cosine wave, and we're going to use this thing column data source, where we specify the data. It's just a way to specify the data, and then all these different tools that we want to have on there, and then we create a plot where they both have the same source, and that will allow us to have the linked brushing when we have our grid plot here. So if we have a look at that, they're not linked for panning, but they are linked for selecting. So if we select, I need to reset, that's not the right one. It'll be this one. So because the phases of the sine and cosine are offset, here we're selecting from, let's see if we can get it just like this. So yeah, we're selecting roughly from 6 to 10, and you can see this one is also selected from 6 to 10, but the y values are different for these 2 graphs because one is a sine and one is a cosine. And so it allows you to see, let's say you have a data set where you have more than one y variable that you want to see how these data are compared. You see an interesting feature on the left one, and you want to see what are those corresponding values, or what are the values for those corresponding points. Say they're samples. What is the other data for those samples in the plot on the right? Well, this allows you to highlight just a subset of the data. So when go back here, when the sine is -1, the cosine is 0. We can see that here if we zoom in really closely. We can see that when the sine is -1, the cosine is 0, and when the cosine is 1, the sine is 0. That kind of thing. So pretty cool that it allows you to do that. Finally, last year there was an issue with this where it didn't work, but I think it's working again. There's a way we can interact with the bouquet plot in the notebook and have it have it be interactive inside the notebook without using the bouquet server. So we're going to use this interact feature from IPyWidgets, and we're going to need this push notebook function that we haven't seen before, and we're going to use this output notebook command, which will output the bouquet to the notebook. So we're now running bouquet inside the Jupyter notebook. We're going to specify some x and y vectors, and then we're going to specify a figure and a line in that figure. And then we're going to make this this function update, which will take parameters from this little widget and update whenever we change them, and we'll push that back to the notebook. So first we can show, so this actually did open up a new tab, but we actually want to go back, and because we use this output notebook function or command, we can now see the plot in the notebook, which is pretty cool. So you can do all the things that we did before, zoom in and out, etc. But then you have this interact function that we imported, and that is going to take as an argument the update function, which will generate these little toolbars. So right now we have a sine wave, but if we switch that to cosine, it will show us a cosine wave. And if we switch it to tangent, it'll show us a tangent curve. And this is all because of this function that says if f is sine, the function should be numpy sine. And then here we have these options for f, sine, cosine, and tan. So the interact and the function work together, and so we can then change these parameters. They have different ranges that they come with, but we can change the period and the amplitude and the offset all in real time. And if you wanted, I think you could even combine this with the brushing and the panning that we just saw to really get some cool visualizations. Now this is more for an interactive, this is even more interactive because it's running in the notebook. I think it would be possible to do to publish the whole notebook online and have this work, but it would take a little more handling. If you really want to just provide an interactive visualization, say as a supplemental data thing for your scientific paper, I would recommend using kind of the more standalone bouquet plot like here, where here we only have this single curve with its parameters, but it will work more easily on a web browser. Any questions on that? All right.